Hello, my name is Dustin Ornchuk, and I'm the lead author of our paper recently published in the Journal of Sport and Health Science entitled Exploring the Associations Between Skeletal Muscle Echogenicity and Physical Function in Aging Adults, a Systematic Review with Meta-Analyses. As a brief background to our study, the assessment and quantification of muscle composition can aid in the diagnosis of sarcopenia and other issues with muscle size and quality. Ultrasonography is portable, affordable, and non-invasive, especially when you compare it to other methods of imaging like MRI or CT, or more invasive methods like muscle biopsy. Skeletal muscle echogenicity, or a grayscale analysis, essentially how bright the image is an established proxy of muscle quality. And the relationships between the skeletal muscle echogenicity, especially of different muscle groups and of different functional measures, were previously unknown. Based on the background, we aim to identify and assess literature examining muscle echogenicity and physical function in adults over 60 years of age. The adults were also non-pathologic. We wanted to qualitatively synthesize this literature and, where possible, perform quantitative, pooled, or meta-analyses. We also wish to perform sub-analyses on the between-muscle relationships between echogenicity and physical function. We started by pre-registering our meta-analysis through Prospero, and then turned to the literature search, where we utilized 5 major databases with the search term that you can see on the screen. This returned 2,251 total studies, and after duplicates were removed, we were left with 1,310 unique hits. We also found 3 additional studies from citation searching or reference lists, and we obtained unpublished data from 13 of those included studies. All told, 51 studies were included in our systematic review. Once we identified the 51 studies, we extracted data such as sample size and demographics, but also scanning plane, the muscles assessed, physical function tests, Pearson's correlations, and many correlations were combined within a single study to adhere to the assumptions of independence. The Pearson's correlations were transformed to Fisher's Z to create a continuous variable, and entered into SPSS to perform separate meta-analyses for knee extension strength, grip strength, walking speed, sit-to-stand performance, and timed up and go. We performed subgroup analyses for the different muscle groups, and Fisher's Z was back transformed to Pearson's R for interpretation. We also performed a risk of bias assessment to rank the studies based on their quality. These 51 studies included over 5,000 participants with slightly more females than males. They averaged 72.5 years of age. Risk of bias came back low for 31 of the 51 studies, with the other 20 returning with some concerns. The most common issues were researchers not reporting their own reliabilities for ultrasound scanning, or if they did, they were in non-relevant populations. There were also some issues with selective reporting where variables that could have been reported in correlations were not. We also examined funnel plots and found them to be fairly balanced, suggesting a relatively low risk of publication bias. Our primary meta-analytical results included several variables, the largest of which was knee extension strength, which included 20 studies and just under 3,000 participants. This returned a pooled Pearson's R correlation coefficient of negative 0.36, with narrow confidence interval bands spanning from negative 0.38 to negative 0.32. Similar findings were true for grip strength at negative 0.31, walking speed at negative 0.23, sit-to-stand performance at negative 0.34, and timed up and go performance at negative 0.26. All metas were relatively heterogeneous supporting the use of a randomized effects model. Regarding the subgroup analyses, there were minimal or at least no clear patterns between muscle differences in predictive ability. However, when muscles were combined, correlations generally tended to be stronger. As we can see in this image, combining the rectus femoris and vastus lateralis, or all four quadricep muscles, tended to have larger correlations with knee extension strength performance than any individual quadricep muscle in isolation. So the key takeaways from our review and meta-analyses were that relationships between skeletal muscle echogenicity and physical function were small to moderate, but highly consistent. The sub-analyses determined minimal between muscle differences in predictive ability. Therefore, ultrasonic echogenicity should be considered as part of early detection screens for sarcopenia and other diseases. Additionally, researchers could consider combining muscles to strengthen their models. Importantly, muscle quality appears to be systemic. Therefore, it's possible that a single scan could represent total body muscle quality. For an example, somebody who is in a wheelchair may not need to change into a pair of shorts to have their quadriceps scanned, but instead a practitioner could scan a easily accessible muscle like the biceps brachii or the deltoid to get a good idea of muscle quality for the rest of the body. Like all studies, limitations exist. Our systematic review and meta-analyses only included older adults, and we did not perform sex sub-analyses. Therefore, results could differ in younger cohorts or when examining male and female differences. Few studies reported subcutaneous fat-corrected echo intensity values, and very few reported both fat-corrected and non-fat-corrected values. 2 studies had very large sample sizes, contributing disproportionately to the meta-analyses in which they were included. Some studies that we found for the systematic review were not included in the meta-analyses due to the fact that they provided multiple but not simple correlations. Future dedicated studies should confirm our theory on systemic muscle quality. Additionally, other meta-analyses and examinations should look at imaging techniques and analyses like echo intensity bands, shear wave ultrasonography, or muscle texture analyses. Additional investigations should include panoramic versus snapshot ultrasonography, subcutaneous fat correction, and the effect of transducer orientation. Finally, it is key to examine whether echogenicity can be positively changed by exercise, diet, or pharmaceutical interventions. We thank you very much for your interest in our study, and we are happy to answer any questions regarding this particular study, any of our previous works, or our future projects. We also extend warm acknowledgments to the researchers listed below for providing additional findings from their previously reported results.